So we just say that the electroscope is an instrument we can use to observe the frequency component of any light source. So when a light is given off by an atom, and due to some energy provided, such like the heat or the electricity, then the atoms of a given element, they will emit only certain kind of frequency of the light. So this frequency is not one, but it is they have several of them, but it is no longer continuously. And therefore, as a consequence, each element will emit their own unique spectrums of the light. So this reason we need to come back here to refresh our memory about what is the electromagnetic spectrums. It is a continuously spectrums, but they can be separated into different regions based on the range of the frequency. You may use the language of wavelengths, but just make sure you're consistent there. Here, if you follow the language of the frequency, at the low frequency, it is the radio wave, the microwave, and at higher frequency, it is UV ray, X-ray. So that's the reason when you went out for the sun bath, you need to put some lotions on the top of your skin, some cream on the top of your skin to prevent to be hurt by the UV ray, because they carry very big energy. But no matter which kind of the EM wave you're talking about, the relation between the frequency and the wavelengths, the multiplication of these two is equivalent to the speed of light. And this speed of light is a constant. So no matter it is a radio wave or gamma ray, they are all moving at the same speed of light. And the whole distribution of the EM wave here, continuously spectrum, is a so-called electromagnetic spectrums. And the light is an EM wave. But the visible light is a very narrow band of the spectrums. So please don't confuse yourself between the visible light and the lights. So let's go back to the electroscopic, the spectroscopic. So each individual element will produce their own, behave like the source when they are provided the heat or the electricity, and they will emit light. So the light spectrum is unique. So when you try to analyze the properties of an element, you have to try to separate this light from individual element into the component frequency. So this is a very important instrument to help us to analyze the property of elements. And the light emitted from every single element, actually, it is a distinctively glow when it is energized. So for example, in this slide, you can see that the sodium will produce a bright yellow light, which makes them useful as a light source for the street lamps. And for example, neon atoms emit the brilliant red-orange light, which make them useful as a light source of the neon signs. So each element actually can produce light, and this light can be separated into different kind of component frequency. And this spectrum, you can see that it is different for individual one. And also, this is the reason why I say it is a distinctively glow. It is because the spectrum is discrete. It is not continuously. So this is a very important thing. So now, if you put the spectroscopic in front of the light source for no matter which kind of element here, what you are going to see is that the light consists of a number of the discrete frequency rather than a continuous spectrum, as I just mentioned. So individually, you can see they have their own unique discrete spectrums. And this kind of pattern of the frequency formed by a given element, some of which are already shown here, is referred as atomic spectrums. And the atomic spectrum actually is the fingerprint for individual elements. So you can notice that the spectrum looks different for all the elements. They never overlap. So that's the reason we say this is element's fingerprint. So you can identify the elements in the light source by analyzing the light through the spectroscopic and looking for the characteristic pattern. So if you do not have the opportunity to work with the spectroscopic in your laboratory, now you probably can check that the figures provided in these lectures. So the first spectrums discovered in our history can be dated back to the 18th centuries, and it is done by the contribution are made by many different people, and eventually the Jonathan Balmers expressed that actually all these line spectrums from the hydrogen can be formulated in terms of the mathematical formulas. So just a reminder to you that hydrogen is the simplest structures of the atoms in the periodic table. They only have one protons and one electrons. But even for the hydrogens, the spectrum is very complicated. So the more complicated of the structure, which means the more protons and neutrons and more electron you have, the spectrum you're going to observe is more complicated. So it is harder for you to formulate in terms of the mathematical formulas. But intrinsically, you will find out in our next lecture is that these spectrums is generated and can be related to the movement of the electrons within the atoms. So by providing them the energy, they will jumping back and forth inside the atoms. And now you will find out we are getting closer to the so-called concept of quantum physics. So everything what we have learned in the previous chapters from 1 to 11, they are the so-called classical physics. And in the chapter 28, we study about the general relativity. They are still considered as a classical physics. So what quantum physics focuses on is about the interaction among the particles. That's the reason at the very beginning of these chapters, we define what is the protons, what is the neutrons, and what is the electrons. So we will continue our discussion in our next chapters.